Hello, welcome to Chapter 9, Section 1, Identifying Quadratic Functions, where we're learning some introductory stuff about quadratic functions. And in this example, number 3, we're going to talk about the direction of a parabola. This is exactly what we covered in the previous video. So it ties in with what we did, except that we kind of start talking more about the equation of it. So this is where we introduce what we call standard form. Standard form means that everything's going to be simplified. So terms have been added together if they're the same, we call them like terms, but if they have the same exponent on the variable, there's nothing to multiply, there's nothing to simplify, there's no parentheses. And after we do all the simplifying, we turn things in the right order to where the part with the x squared comes first, the part with the x comes next, and then whatever the number is that's left, which, spoiler alert, has x to the 0 power, but more on that when you get to Algebra 2, that's last. So the exponents, we talked about this in Chapter 7 when we introduced polynomials, but the exponents go in order from 2, the hidden 1, and then of course the 0, which, like I said, we'll talk about that later. Now, before I say more about this, I just want to point out this right here, ax squared plus bx plus c, that's something that we covered in Chapter 8 when we talked about factoring polynomials that look like that. That was actually 8-4. And if a equals 1, so you don't see it, x squared plus bx plus c, we talked about that too. What two numbers multiply to give c and add to give b? And that's how we factored it. That is going to come up later when we start to solve quadratic equations. So everything that you learned in that section is going to pay off as we learn more about quadratics. Remember, math uses the stuff we've learned before and it builds upon itself. A couple other things. You cannot let a equal 0. A, b, and c can be any numbers that you want. They can be positive, they can be negative, they can be fractions, they can be irrational. They can be any numbers at all, with this one exception. You cannot let a equal 0. Why? Because if a equals 0, whatever x is, 0 times whatever that is 0, which means it goes away. And if that goes away, now I've got something times x plus something. Now it's no longer quadratic, it's linear. If I let a equal 0, my x squared is going to go away. And remember from the first video, the first example, you have to have an x squared. So that's why we say, hey, don't let a equal 0. All right? Okay. We'll be talking more about this as we explore. There's so much stuff here. But again, we'll be coming back to like what this all means and what we can do with it and how we can graph it and how that tells us where the vertex is and how it tells us what the minimum and the maximum could be. We'll get into all that later. There's a lot of information here. So for this video, we're just going to look at one thing. I know a cannot be 0, okay? That means that a has to either be positive or negative. Just like in the last video that I showed you, we had y equals 2x squared. My a was positive 2. And if you remember, that graph looked like that, which we call smiley face. In the second example from the previous video, we had y equals negative 2x squared. For that equation, the a was negative 2, and our graph turned upside down into a frowny face. All right, and by the way, I want to mention one thing real quick. A, b, and c are not variables. They're what we call parameters. Parameters are not variables. The only variable I have here is x to the second power. I'm sorry, excuse me, x. I know there's an x to the second power. The only variable I have is the x and y, which could be written as f of x. So a, b, and c are not variables. We're going to really emphasize that. Okay, so how do I figure out what direction a parabola is going to go? Is it going to be upwards like a smiley face or downwards like a frowny face? I need to put it in standard form, which basically means leave f of x or y on the left side and move everything over the other side. And then I need to figure out do I have a positive or negative in front of the x squared? So let's do a couple of examples. First one, this is already in standard form. My a is positive 4. My b and my c are both zeros. Now you're probably thinking, you said you can't let them equal 0. No, that's not what I said. I said you can't let a equal 0. B and c can be anything you want. As long as I got an x squared, I got a quadratic. Since that 4 is positive, this opens upwards. And you need to not only just tell me upwards, but you need to tell me why. So why does it open upwards? You can either say, you pick one, your choice. You can either say because a equals positive 4. You can say because a is positive. I mean, you can just literally say, well, a is a positive number, it's positive 4. Or you can even write the same thing, except write it this way, a is bigger than 0. That's a fancy way of saying a is positive. So you can pick one of those, I don't care. Let's do the second one. Now, for the second one, I see 2 in front of the x squared. 2 is positive. This must open upwards. And if I say that on a test, I'm going to get it wrong. Now, pause for a second. Hopefully you've restarted the video. Why would that be wrong? Because this is not standard form. I have to have y, or f of x, that's an f of x, that's a y. I have to have y all by itself on the left side. So I need to move this 2x squared over to the other side. The opposite is to add negative 2x squared. And I get y equals negative 2x squared plus 5 in standard form. Not 5 subtract 2x squared. I got to put it in standard form. So the a is going to be negative 2. This doesn't matter for this problem, but it's good practice. The b is 0 and the c is actually 5. That's the c. Why is the b 0? Because I don't have any x term. Since a is negative, this opens downwards like a frowny face. And again, you can say because a is negative 2, because a is negative, I don't have space here, or you can say because a is less than 0. You don't have to say all three. I've done this so many times, I'll give you the choice and people still write all three. Just pick one. Pick one, whichever one makes sense. I'm good. This one's already in standard form. I have f of x equals negative 4x squared minus x plus 1. This is already standard form, so this is okay. My a is negative 4. You don't need to know this. I'm just doing it to set this up for later. My b is going to be negative 1, and my c is going to be positive 1. But it's this one right here that determines which direction it's going to go. So this one opens downwards. And again, you can either say because it's negative 4, or because it's negative, or because it's less than 0. Which less than 0, all the numbers that are less than 0 are negative. Alright, we'll do one more. This one, again, tricky like that one up there. I see a negative 5 in front of the x squared. I want to say it's downwards, but unfortunately it's on the wrong side. So the first thing I have to do is I have to add 5x squared to both sides. On the left side, I just get my y. On the right side, I've got 2x minus 6 plus 5x squared. I can write that, but I need to put it in order. The 5x squared comes first, then the 2x, then the subtract 6. My a would be 5, my b would be 2, and my c would be negative 6. Since my a is positive 5, I kind of smeared it a little bit. This opens upwards. And again, you can say because a is 5, positive 5, or a is positive, or a is greater than 0. Any of those work. Okay, we'll see you in the next video.